second form of test 6. And this is asking, given this data here, given this information, given the vertices of the sides of a triangle, find the centroid. Well, we like to use that nice formula. So I'll take the average of the x-coordinates, 7 plus 11 plus 9, which is 27, divided by 3, and that's 9. The average of my y-coordinates would be minus 1, minus 3 is minus 4, minus 5, that's minus 9 divided by 3, so that's minus 3. 9, negative 3 would be the point of concurrency of the medians of that triangle. Here's what you're taking a look at graphically. Notice at 9, negative 3, boom, stick, you actually have that centroid. My fifth example, and I'll clean this up. I don't want to go online, Melissa. I'll clean this up. My fifth example gives you this triangle, and we have to find the circumcenter of the triangle. We're also told in this example, I'll just go back to your notes, an equation of a perpendicular bisector. And we like that because that provides us a lot of information, and it requires us to only find one more equation of a line. So I have 3y equals minus 5x minus 33, and that is the equation of segment AB's perpendicular bisector. So if we were to look at the perpendicular bisector, let's see which one I made. This is the perpendicular bisector of segment AB, and that line has equation 3y equals minus 5x minus 33. So we just have to decide which other equation we want to focus in on. We focused in on AB. Why don't we focus in on BC? BC's perpendicular bisector equation, well, we would want to find the slope of BC. The slope of BC, you take your 0 minus minus 5 divided by minus 10 plus 7. So you have 5 divided by negative 3. All these numbers are so similar. I wonder if there's a pattern or something to me making this. The slope of the perpendicular bisector would be 3/5. Now we need to find the midpoint of segment BC. The midpoint of segment BC, negative 10 plus negative 7 is negative 17 divided by 2. 0 plus negative 5 is negative 5 divided by 2. You're a little scared by those fractions, but guess what? It's all good. So you're just going to have y plus 5 halves is equal to your 3/5 times x plus 17 halves. So when I take that and clean it up, I multiply everything by 10. Didn't I do that in the other example too? Interesting. So if I multiply that by 10, I have 10y plus 5 divided by 2 is 5. 5 times that 5 is 25 is equal to 10 divided by 5 is 2. 2 times 3 is 6. Times the quantity x plus 17 halves. So I have 10y plus 25 equals 6x plus 6 divided by 2 is 3. 3 times 17, I think it's 51. So now I have this equation with 2 variables. I have this equation with 2 variables. I think I'm ready to go. I might even clean this up to 10y is equal to 6x, and then 51 minus 25, that would be a whopping 26. So that cleans up to be 5y equals 3x plus 13. I can remember that. So 5y equals 3x plus 13. 5y equals 3x plus 13. And then we go to that other equation that was given to us. 3y equals negative 5x minus 33. 3y equals, I just lost my, minus 5x minus 33. So we've got that. Minus 5x minus 33. So here I'm going to multiply this by 5 and this this by 3. So 25y is equal to 15x plus 65. And this is 9y is equal to negative 15x minus, and that's a 99. So I get a 0, I get a 34y is equal to, and then I go over here, 99 minus 65, I guess we could have done 100 minus 65. We get a 4, 9 minus 6 is 3, so that's actually minus 34. So y is equal to negative 1. If y equals negative 1, I can take any of my equations and just PII. So I have 5 times negative 1 is equal to 5 times negative 1 is equal to 3x plus 13. So that's minus 5 is equal to 3x plus 13. Add 13 to both sides. 3x is equal to, I'll subtract out and I'll get a minus 18. So x is equal to minus 6. So minus 6, negative 1, is the circumcenter of that triangle. And if we were to look here at my perpendicular lines, and I look again, negative 6, negative 1, that's what we found. That is the point of concurrency of the perpendicular bisectors. The one thing that I was going to say is, because notice the line segment AB and line segment BC, the slopes of those line segments are opposite reciprocals of one another. Therefore, that angle, ABC, is a right angle. Therefore, the circumcenter is actually on the hypotenuse of the triangle. That's not always the case, but wow. If you can identify that, then you could just go to the hypotenuse and find the midpoint of that hypotenuse. The final example of this little demo is to find the orthocenter of the triangle here, and you've only been given vertices. So with orthocenter, you need to find the equations of the altitudes of the triangle. So why don't we go for it? I have to focus in on that vertical line, so I'm going to find this PD's slope. And PD's slope, because it's a vertical line, is undefined. Therefore, its perpendicular slope would be 0. We know that point E has coordinates negative 7, 3. Therefore, if I have a slope of 0, that means that we have a horizontal line. Remember, horizontal lines are y equals the real number, y equals 3 in this instance. You could have actually put this into point slope, and you would find that y equals 3, but there's no need to. And we really do need to be at the point where we understand that. Now we have to think of one other altitude as equation. So let's focus in on ED. ED's slope is, I take 3 minus minus 1 is 4, divided by minus 7 minus minus 9 is 2, so that's 2. So the slope of the perpendicular is a negative 1/2. And if I'm working with ED, then I need point P to be the point from my point and my point slope for my point slope form. Therefore, I have this y minus 7 is equal to negative 1/2 times x plus 9. So y minus 7, oh, silly Burkhead. Why don't we multiply everything by 2 here? So I have a 2y minus 14 is equal to minus x minus 9. So now I have 2y is equal to minus x, add 14, excuse me, to both sides, so I have a plus 5. So now I have y equals 3 and 2y equals minus x plus 5. Those two circled equations, I want to solve that system. Well, I already have what y equals, so I can just plug it in. 2 times 3 is 6 is equal to minus x plus 5. So x is actually equal to negative 1. So x equals negative 1 and y is equal to 3. Let's look. Negative 1, 3. Here are those perpendicular lines. And I'm quite excited, and when I say quite excited, I mean quite ecstatic. -1, 3, that is the point of concurrency of the altitudes of the given triangle. So, that's it. I know it was a quick little